Hello my dear students, welcome to our AriserTalent. I am your maths teacher Arpita Sharma. Students, we were discussing about triangles. Okay, so the chapter we are talking about is what? Chapter 6, that is triangle. Right students? And we have proven the Pythagoras theorem, and after proving Pythagoras theorem, what we are up to this converse of Pythagoras theorem, right students? Okay, so look at this. Converse of Pythagoras theorem is what? In a triangle, if the square of one side equals to the sum of the squares of other two sides, then the angle opposite side is a right angle. Okay, so we have to prove that. If we are taking any triangle, let's suppose A, B, C, that's A, that's your B, and that's your C. Mark it students. Now, it's saying that if AC square equals to AB square and B plus BC square. Why? Because it's saying that sum of the squares of other two sides is equals to what? Square of one side, right? So, let's suppose that AB and BC are two other sides and AC is what? One remaining side. So, we have given with the information that what? AC square is equals to AB square plus BC square students. AC square equals to what? AB square plus BC square. Now we have to prove that this is a right angle triangle. So for proving this, I am doing a construction. Now look at this, that what I am constructing. Okay, so I have constructed a right angle triangle D, E and F, or PQR. You can name it in any way. Okay. And I am constructing this triangle DEF such that angle E is 90 degrees. So, it is a right angle triangle. Now, I have constructed DE equals to AB and this EF equals to this BC. Okay, students. Now, by construction, I am having what? By construction, I am having what, students? I am having AB equals to what? Say D, right? And this BC equals to EF. Okay. And what? Angle E equals to what, student? Angle E equals to 90 degree. Now, why I am doing this? Because I have constructed this and this side equals to this and this side. If somehow I prove, then these two sides are also same. So, what will happen? I am having three sides, okay, equals to these three sides. Then, if these three sides are corresponding equal, then what will say? Then these two triangles are congruent, okay, and if these two triangles are congruent, then what will happen? This will happen that these angles will also be what? Same. So, we have constructed 90 degrees, so it will be proved that it is 90 degree angle. So, we are doing this. Now, again with our process, we have given this information and I am marking this equation 1 student. Now, come here for proof. Here students, this side. Now, I am given in a right angle triangle ABC, no, our construction DEF. By Pythagoras theorem, what I am having, okay, we have proved it that the hypotenuse square, that is DF square, is equals to sum of the remaining side, that is D square plus EF square, students? EF squares? Okay. Now, I am having this AB equals to DE and BC equals to EF. So, what I have to do? I have to just put these values here. Okay. So, DF square equals to DE is the AB square plus EF equals to what? BC square. Now, students, what? This is by construction. This is by construction. We can say AB equals to DE and EF equals to BC, right, students? This is by construction. Now what will we do? This is AB square plus BC square, but by equation 1, what we are having, students, here? Say, here we are having what? AB, no, AB, not AB, that is AC. AC, right? AC square is equals to what? AB square plus BC square. So, if this is the second equation and this is our third equation, ठीक है, which is given here we have given with this information. So, by equation 1 and 2, what we are having? DF square equals to AC square. It's so obvious. AB square plus BC square equals to AC square, and this DF square is equals to also AB square plus BC square. So, DF square will be equals to AC square. Now, what will be concluded? That DF equals to AC. Okay. So, now student, I am rubbing this part only, okay? Okay. So, students, by equation 4th and by construction, that is what? AB equals to D and BC equals to EF, BC equals to EF. This implies what? These three sides BC, AB and this AC is equals to what? It's D, EF and DF. So, by side congruency, we are having what? These two triangles congruent to each other, students, right? So, by SSS congruency, okay, I am rubbing it till here. We are having what? Triangle ABC is congruent to, students, what? Triangle DEF, isn't it? So, angle ABC will be equals to what? Angle DEF. By congruency, we can say this. Now, angle DEF equals to 90 degree. That's by construction. So, now what? Simply we can say that. So, triangle ABC, angle ABC equals to also what? 90 degree. So, triangle ABC is what? Right angle triangle. Right angle. I am rubbing this completely, okay? So, this is what we have to prove, students, right? that ABC is a right angle triangle. So, we have proved it. Okay, students, copy it so that we can go to the next question. Okay. I'm rubbing this. Okay, students. So, next move is here. ABC is a right angle triangle. Okay, at C, let BC equals to A, CA equals to B, and AB equals to C, and let P be the length of perpendicular from C on AB. So, we have to prove CP equals to AB, and the second one is 1 upon P square equals to 1 upon A square plus 1 upon B square. So, let's see that what are these A, P, B, C, P. Okay, what all are these? So, what we will do? We will simply do what we always do, and this is, we will make diagram, right? Okay, so this is a triangle ABC. Now we have given with this that right angle at C. So, this will be surely C, and let it mark A and B here. Now, let BC equals to A. Okay, mark BC equals to A. Now, AB is given, C, and AC is given what? B. Check it out. BC equals to A, CA equals to, CA is here, CA equals to what? B, and AB equals to what? C. And let P be the length of perpendicular from C on AB. Okay. So, this is our perpendicular from C, right, students? So, its length is what? This P. Okay. And this is again what? Right angle triangle, student. So, now we have given this figure in words here, and we have to prove CP equals to AB, and the second one is 1 upon P square equals to 1 upon A square plus 1 upon B square. Okay, students. So, draw this diagram. Okay, students. So, starting with the solution part, here, if we see this angle, triangle ABC, if we'll see in this triangle, taking in triangle ABC, taking what? AB as base. Okay, so if I am taking this as base, then this is the height. Okay, so area triangle ABC equals to what? Half multiplied by base multiplied by height, students. Okay, students. Now, if this is base, so what will be equals to? That will be AB, and that will be height. Height is what? This. That is, let's name this point. This point. Okay, here this point as D. Okay, this is point D. So, AB, this is base, multiplied by what? CD. Right, CD here. Now, value of AB equals to what? AB is equals to C is given. Okay, write C here. And CD equals to what? We have given P, small p. Okay. So, this is our, we can say, first equation. Okay. Now, coming to the second equation, again, area of triangle ABC equals to half. Now, base and height. Okay, wait. We are taking this BC as base this time. Okay. So, taking base BC in triangle ABC. Okay, students. So, what we'll be having? We'll be having base equals to A and height equals to B. Okay, students. Now, this is equation what? This is equation second. Okay. So, what will I do now? Can I say this equals to this? Because these are two same area of triangle ABC. Okay. By equating equation 1 and 2, what I am having is 1 by 2 multiplied by C multiplied by P is equals to 1 by 2 multiplied by A multiplied by B. Now I can cut it out, and what will I be having? That will be equals to CP equals to AB, which is nothing but the given expression, students. Note it. Okay. Note it completely, then we will move to the second part. Okay, students, I hope you have noted. So, I am rubbing this and leaving this, that I am assuming this that we have proved it. Okay. So, it's written here. It's written here. So, now I can use this in our next equation. To prove the next equation, we can use this equation. Okay, students. So, this was for the first one, CP equals to AB. To prove that one, now we'll be doing the second part here. Okay. Applying the Pythagoras theorem here for the second part in triangle ABC, we can say that this AB square equals to what? This AC square plus this CB square. Right, students? We can say this applying Pythagoras theorem. Okay, because this is right angle triangle at C. Okay. Now, AB is equals to what, student? You can say this is C square. That will be AC. AC is what? Equals to B square. Then plus CB. CB is what? A. So, we can say A square. Now, value of C, we have proved that one, students. Right? We have proved that one. So, here we can say that value of C is what? AB by P. Okay. So, we can say that CP equals to AB implies that P equals to AB by, no, that's C. Right, students? C equals to AB by P. Putting value of C in terms of what? In terms of A, B and P, what will be having is A, B by P whole square equals to B square plus A square. Right, students? Now, this will be A square, B square by P square equals to B square plus A square. Okay. Now what? We have to prove 1 by A square, 1 by P square equals to 1 by A square plus 1 by B square. Okay. I can write it A square plus B square. Now students, I can write this A square by B square here. Okay. So if I write this here, then I'll be having what? 1 by P square equals to A square plus B square upon A square B square. Now this A square plus B square upon A square plus B square, how can I rewrite it? Equals to 1 upon A square plus 1 upon B square. Those who are not able to understand, let me rewrite it like 1 upon A square plus 1 upon B square equals to what? A square B square, that's LCM. Now B square here plus A square here. So ultimately 1 upon A square plus 1 upon B square will give you what? Will give you A square plus B square upon A square B square. So this is the same term. I have replaced it with this. Okay, students. So can I simply pick the values of, I'm rubbing this, I'm picking up the values of my benefit only. So this 1 upon P square will be equals to what? 1 upon A square plus 1 upon B square. Okay. And this was the exact thing we have to prove. Okay. Note it, students. I'm going to rub this. Okay. Okay, students. So now I have done with this part. Okay. Okay, students. Now I'll be discussing one more question with you. So this question is, if ABC is an equilateral triangle. Okay, ABC is an equilateral triangle of side A, then prove that its altitude is root 3 by 2a. Okay, students. So this is our question. This is our next question. So let's try solve it. Again with the same, I am having an equilateral triangle. Now what does an equilateral triangle means? That each and every side of this is equal. So I am having this triangle ABC such that what? This triangle, this side AC equals to A, this side AB equals to A. It's given na, that the side is A. So BC equals to A also. Look at this. This is the equilateral triangle. That means AB equals to BC equals to AC and the side is equals to A. So this these three sides will be equals to A. Now we have to prove that the altitude is. So the altitude will be what? Draw an altitude here. So it's basically 90 degree and we have to find that what is the value of this. X equals to what? Okay. So we have given what? The informations are AB equals to BC equals to CA, right students, equals to A, and we are given with the altitude. Let's call it D. So we have given that AD is perpendicular to what? BC. Now more information about this is nothing but we have to prove Okay, we have to prove what? AD equals to root 3 by 2a. Okay, students. Now, proof in right angle triangle, that is ADC. What we are having, AC square will be equals to what? This is a hypotenuse, so hypotenuse will be equals to, square of hypotenuse will be equals to base square plus perpendicular square. Okay, so that's A, so that will be A by 2, because perpendicular of equilateral triangle lies bisected, it's also its median. Okay, so it will be A by 2 and it will be A by 2 also. We have read all these, we have learned all these properties of triangle, equilateral triangle, isosceles triangles in our previous classes. Okay, students, so I'm just telling you, I'm acknowledging you that if you are having the equilateral triangle and if you are having the altitude of this triangle, then it will divide this opposite side in two equal parts. So if it's A, it will be A by 2, it will be A by 2. So AC square will be equals to AD square plus DC square. Okay, now AC is what? A, so A square plus AD. AD square is what we have to find. We can just write AD square plus DC. Now DC is A by 2 whole square, right, student? So you can simply write it like A square equals to AD square plus what? A square by 4, students? No. Now AD square will become what? A square minus A square by 4, that will be equals to 4A square minus A square, that will give you 3A square by 4, right, student? Okay, so it will give you what? AD equals to root of 3A square by 4. Now root 4 equals to 2. Okay, so by 2, A square root, that is A, and root 3 here. So I can write it like root 3 A by 2. Okay, so this is, I have to prove, this will implies that AD equals to root 3 by 2 A, and this is something what we have to prove. Okay, students, note it. Okay, so students, what I am saying to you is important now. This is the last session that of this chapter, this particular chapter triangle. I have covered all the theorems and approximately all the questions in that, but some miscellaneous, I will always have some miscellaneous exercise in your all chapters. So what we are going to do, that we will study some questions, mixed questions, some theorem, mixed theorems, and some and we'll talk about some important questions for your board exams. Okay, so see that lecture. Okay, now till then, keep enjoying and keep watching, keep studying. Thank you.